So for the assessment for the asymptotic notation for question 1, I said that it was true, and kind of my reasoning for this is that the omega n is just the lower bound, so it just has to be above that. And since O of n squared is above that, then technically it can be part of the, it could also be O of n squared. And then for number 2, if a function is in theta n, big theta n, then it could also be of O of n squared. And this is true because big theta n is more of like the equal, like, so it has to, like, most of the time, or it is like runtime of n, and O of n squared is like the upper bound, so n is smaller than n squared, so it's not like higher than n squared, so therefore this also works. And then for number 3, if a function is in omega, big omega n, then it is always in on, which this is false. And my reasoning for this is the big omega n is like the lower bound. So then it can be higher. So it could be like, I don't know, on squared, and basically it could be anything higher than n. And right here it says like always O of n, which is not the case, because it isn't always the situation, because it could be larger, like it could be O of n squared and such. And then for the sorting and identification, right here, I said that this is merge sort, which for me, like, at first I thought that it was insertion, but then it's merge sort. So the reason why it is an insertion is because you could see that the 1 was moved to the left 1, and for insertion sort, it's like starting from the beginning and it goes, 0, blah blah blah, so like the front is sorted, but the back doesn't like start sorting. Like, you get to the point and then you like move over the array, the sorted part, and then you like put the current wherever it needs to go, right? But right here, like, it would not start sorting like that. Like, it would just move over everything and then like insert the 1 wherever it needs to be, so between the 0 and the 2. And it's not selection sort, because selection, it would already start like having the first value, so it'd be 0, 1, 2, 3, and so forth. But here's like 0, 2, 4, so it hasn't gone through the whole array. And it is merge sort, because if you split it off, then you can see that the 0, 2, 4, 7 part is sorted, and the 1, 6, 3, 5 is currently like being sorted. So that's kind of like where it is during the sorting. And for the recurrences, for question number 1, I said T of n is equal to 2t n over 2 plus n. And for this case, first of all, I have the 2t because the recursion is happening twice. Like, there's 2g of n comma ss times 2 statements. And then for the t, inside the parentheses, it's n divided by 2, because as ss multiplies by 2, the time halves by 2, since it's like going up on 2, and then the base case is ss is greater than n, so it like halves. And then the plus n is for the for loop, because that's like kind of the printing debugging check of part for the recurrence relation. And then for the recurrence diagram, right here I have at the top level, it starts with the n, it prints out 0, 1, 2, 3, 4. Then you go down a level, and the runtime becomes like n over 2, and it starts printing like 0, 2, 4. And then the amount of tree levels is log n levels, and then the runtime would be n log base 2 of n. And the bottom part, yeah, the base ends when n is like right below, when ss is right below n, so like the next time it runs, ss would be greater than n. And yeah.